Good morning, everybody. Mr. Shuck here. How are you? We're going to talk about Advanced Algebra Section 1.1. And I'm recording this on Zoom, and I'll do the best I can to get this done accurately and neatly so you can all see it and read it. But we're going to go fairly quickly here. Section 1.1 is very dry, very boring. It's a lot of number theory stuff, but it's things we have to take care of, and we're going to do that as quickly as we can here, okay? We'll try not to bore you too much. First thing we want to talk about are number sets. Okay, this is section 1.1 in advanced algebra. We're going to talk about what we call number sets. Okay, I'm going to draw a diagram here. I hope you're going to be able to see this on the screen here. It'll be kind of strange for me. But we're going to start off with a simple problem set of numbers called the whole numbers. And whole numbers are basically just that. Whole numbers starting at 0, 1, 2, 3, and so on. Those numbers are considered whole numbers because they're whole. No parts, no fractions, no decimals. Take away the 0 and start with 1 and go 1, 2, 3. Those are counting numbers. They're called the natural numbers. I'm not going to list that as a separate unit, but just thought I'd throw that in there. Now, we know that sometimes numbers are negative. So if we include the negative numbers, those are called integers. The integers include all the negative numbers, -3, let's say, -2, -1 to 0, and all the positives as well. I'm going to draw another bubble that has the integers surrounding the whole numbers. And that indicates that every whole number is also in the integer group, okay? Then there's another group of numbers. If you understand, all these are kind of whole numbers. We haven't talked about fractions or decimals and things like that. Where does the number 1/2 fall? Well, those are called rational numbers. I'm going to use the number symbol just to save some room here. Rational numbers are fractions, like 1/2, 0.75, 1/3. These are all examples of rational numbers, fractions and decimals. And does that mean an integer is rational as well? I mean, can I write the number 3 as a fraction? Of course I can. Or how about 4? 4/1, that's a fraction, but we know 4/1 is just 4, so that's also an integer or a whole number. So rational numbers are numbers that can be written as fractions and decimals. And when they're written as a decimal, the decimal stops, like 0.75, or repeats, like 1/3, that decimal would be 0.333 repeating. So those are all called rational numbers, all right? Oops, forgot a little deal there. Okay. Well, there are some numbers that we call irrational. And those are those decimal numbers and fractions that don't ever end as a decimal form, or don't repeat. For example, pi. We know that pi is 3.14 blah, 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 blah. It goes on forever and never repeats. That's considered a rational number. A lot of radical numbers, square root numbers, end up to be irrational, okay? So that's another group of numbers separate from the other group because they're different. None of these numbers in the irrational column or bubble fit into the rational. They're different. But when we combine all of these together, all of those numbers are called the real numbers. And you will see this funky little capital letter R with a double bar in front representing the real numbers. So those are some basic number sets. So terminology is really important here when we start talking about numbers. When your teacher talks about a whole number, you should know what that means. What's an integer? Real numbers are basically every number you've ever worked with before. There's going to be some numbers we haven't seen before that we're going to learn about, like the number E. Believe it or not, we're going to learn about that later on this year. So that's the real number set, okay? Again, hopefully you've written this down. I'm going to take it off the board because I'm unable to flip chart this on Zoom. So we're just going to move on to the next phase, all right? Second part of the lesson, real exciting stuff are properties. You're going to want to write this down, so follow along, please. There's properties, properties of addition and properties of multiplication. Okay. These are basic algebraic properties that you probably have learned before in the past, all right? And the first one I want to talk about is called the commutative property. The commutative property, hopefully you can see that. My writing isn't always great, but do the best you can. It is right in your book if you ever want to reference it in your book. The commutative property says basically this. If I have a number A plus B, that's the same as taking B plus A. In other words, the order in which I add two numbers together doesn't matter. Same with multiplying. A times B, well, that's the same as B times A, right? 2 times 3 is the same as 3 times 2. The order doesn't matter. I should have started this off by saying we are going to begin with letters or numbers A, B, and C. We're going to consider them to be real numbers, all right? So we're talking about any real numbers that you can add or multiply together here. Okay. Second property, let's talk about the associative property. The associative property talks about grouping numbers together. So if I have an A plus a B plus a C, and I add them together over here as well, but suppose I group A and B together. Maybe I add those together first. Does it matter? Because maybe I want to add the second two together first. Will I get the same answer? The answer is yes. So it doesn't matter how you group them together. And of course, with multiplying, it's the same principle. It does not matter what group of numbers you multiply together first. Okay, that's called the associative property. You get the same answer. Identity. The identity property. Think about identity as how does a number keep its identity? With addition, it's kind of simple. If I have a number, what can I add to that number so that it stays that number? Well, I add 0, right? A plus 0 gives you A back again. And I could have the 0 first if I wanted to. Again, that doesn't really matter, okay? But with multiplying, it's a little different. So if I have a number that I want to multiply by, and I wanted to keep that value, I wanted to keep its identity, I'd multiply by 1. So I can multiply any number by 1, and my number keeps its identity. Inverse. The inverse property. Here's where it gets interesting. We're going to learn a couple new terms here. The inverse property goes like this. With addition, it's if I have a number A, what can I add to it so that I get 0 for an answer? This number here would be called the opposite, all right? And we'll talk about that in just a minute. This is considered the opposite. So every number has an opposite that'll get you to 0. When you multiply, if I have a number, I'm going to multiply by what we call its reciprocal to get 1. Okay? So there's some new terms here. This would be considered the opposite. And this, of course, we've seen that before. That's called the reciprocal. Okay? So I'm not going to Every number has a reciprocal and every number has an opposite, okay? And we sometimes call this the additive inverse, right? The additive inverse, and this would be the multiplicative inverse. Sometimes that's an interchangeable term for reciprocal. Sorry about that, I get trouble with my R's here. All right. The last thing I want to talk about is something called closure. Kind of running out of space here. Closure. Closure is simply this. If I'm starting with real numbers, my answer is going to be a real number, okay? So if I'm adding two real numbers together, I will get a real number for an answer. In other words, my answer stays within the set of numbers I'm working with. It's got closure. Same with multiplication. A times B will also give you a real number for an answer if you're starting with real numbers, okay? All right, there is another property called the distributive property, which I think we all know about. Not a big issue here, but real quick. If you want to talk about the distributive property, it's kind of a unique distributive. If you have a number being multiplied by a sum, so now we're kind of combining multiplying and adding together, right? You get your A times your B plus your A times your C. And it wouldn't matter if the A or the number being multiplied is last. You know, maybe it's written second here or at the end of the parentheses. It's still going to give you A times B plus the A times the C. Okay, that's called the distributive property. You guys have already known that, I would imagine. Okay, so what are we going to do? What does all this fun mean? Well, one type of problem you might see is going to be very simple. If I give you a number like the number 3/4, I'm going to give you a number and I'm going to ask you, where's that? What kind of number is that? Well, you're going to go back to your list and you go, oh, that's a fraction, right? And that's 0.75. So this is a rational number. And if it's rational, it's also a real number. Is 3/4 an integer? Well, no, because it's a fraction. Okay. So that's one type of problem you're going to have to do maybe on a test or a worksheet, is just identify all the number sets that a number belongs to. You might be asked to have a group of numbers and write them on a number line. You might be asked to do that. So you're going to start off with a number line and you're going to be asked to place numbers on the number line. I know this sounds kind of simple, but we're just getting started here, right? So 3/4 might end up there on a number line. So you might be asked to do that. How about the square root of 5? Where does that end up on a number line? You know, a little over 2, huh? 2 point something. You put square. So you're going to be asked to do that as well. Okay. So those are some real fun facts on number theory, number sets. Not all that exciting. All right. Then also in section 1.1, we have this idea of unit conversion. Unit conversion, I don't know why it's in this section. It's kind of out of place, but we got to talk about it, and we're going to go through a few things. So one thing I need you to remember are, here are some unit conversions that maybe you don't really know. I want you to remember that 1 mile equals 5,280 feet. Okay, that's a unit conversion most people don't know. Also, we don't do this very often, but 1 mile is also 1.61 kilometers. Not too often you convert miles to kilometers, but that's going to be a unit conversion that you're going to want to know. I found out that many people don't know this, which is kind of weird to me, but we have a unit of measurement called a ton, and that's 2,000 pounds. I was asking some college students if they knew how much a ton was. They had no idea, so I'm gonna throw that in there. But there's also inches to feet and all that jazz, which most of you should know. So we're not going to go any further than that. Those are some basic unit conversions that we need to put in our memory bank. Okay, I'm gonna erase this from the board so we can do some problems. Okay, ready? Okay, some simple problems. How would I convert or find a unit conversion of something like this? What if you work 8 hours, okay, and you earn $60 for the day, okay? Question is, how many dollars per hour did you make? So that's called a unit rate, all right? How do we handle that? Well, pretty simple. Your dollars goes on top, your $60 goes on top, your hours goes on the bottom, and all we're gonna do is divide that out, and you get about $7.50 per hour, okay? Just divide that out, use a calculator, have at it, all right? Another type of problem might go like this. That's example A, here's example B. Suppose you buy 18 gallons of gas and the cost is, what do I got here? $2.65 a gallon. Okay. How would I find out how much money I spent? Okay. How much was the total cost? In this particular case, I think we've all been to the store or the gas station and bought gas before. It's simply going to be 18 gallons of gas at $2.65 per gallon. You're going to multiply that out, and you're going to get $47.70 for a grand total, right? So those are some simple unit conversions. They get more fun. Here comes a test question, all right? I'm going to do one of these, and then we're going to move on here, all right? Suppose we have 90 kilometers per hour, okay? I'm going to go 90 kilometers per hour, and I want to know what is that speed in meters per second, okay? Practice test question right here. 90 kilometers per hour, I want to convert that to meters per second. So I want to convert kilometers to meters. I want to convert hours to seconds. And here's how I'd like you to see to work this out. Write down your original fraction. Include your units. 90 kilometers for 1 hour. What we are going to do is multiply by conversion units, okay? So we got to ask ourselves, let's convert kilometers to meters, or we can convert hours to seconds first. It doesn't matter. I'm going to convert meters or kilometers to meters. So our kilometers are on top here in the numerator. I'm going to put kilometers here in the bottom, the denominator, so that they cancel, okay? And I know that 1 kilometer, you should know that that's 1,000 meters, okay? My kilometers have canceled. I've got meters for a final unit. That's what I want. That conversion's done. Now I got to convert hours to seconds. Okay, make another fraction. Love fractions, don't you? 1 hour. Hours are on the bottom here. Hours are going to go on the top here. Okay. And in 1 hour, I know that there are 60 minutes. Okay. So the hours cancel. But I'm left with minutes, and I want seconds. So I got to go one more fraction. Convert minutes into seconds. And I know that 1 minute has 60 seconds. And my minutes cancel. And I'm left with my meters on top, seconds on the bottom. I know then I'm done with my conversion. Now I just deal with the numbers that I have left over. I've got 90 times 1,000 times 1 times 1, which you don't really have to do, all over 1 times 1 times 60 times 60. Again, if you multiply all that garbage together, you get 90,000 on top. You get 3,600 on the bottom. And then you multiply all that fun together. Or divide that out. I think you get 25 meters per second. And that would be your final answer. Great unit conversion. All right. All right. That was good stuff. Okay. Real quick, and then I'll be done here with section 1. Suppose I'm in Minneapolis, another example here, and I'm going to Winnipeg, Canada. Okay, I'm going to Winnipeg. Bad spelling, Winnipeg. And suppose that's 450 miles. What if I wanted to convert that to kilometers? I would take my 450 miles, convert that miles on top, miles on the bottom. I know that 1 mile is 1.61 kilometers. That goes back to that unit conversion that I gave you earlier. My miles cancel. Should have MI, I suppose. And all I have to do there is take my 450 times 1.61, and I get 724.5 miles. So there's going to be some simple unit conversion of that nature as well. Well, I tried to be quick, tried to get you some quick examples. Hope you could follow along here. Again, you can always restart the video and stop it as you go if I went too fast. All right, so that's section 1.1. We'll be back with section 1.2 in just a little bit.